talking about volume, and we're just going to go through various formulas, various ideas three-dimensionally, and hopefully this can help you on the test. So here's some names for the most basic solids we have. We have a, really it's a box. We call it a rectangular prism. So a prism is any sort of shape. It could be a triangle, it could be a hexagon, and it's just a matter of extending that backwards. So it is a solid and actually takes up space. So that's a prism. And there's plenty of the prisms here on the page that I'll point out. This ball is a sphere. This is a cube, which is also it's what we call a square prism. We have a cone. We have a pyramid, which is here is actually a square pyramid. Again, now we have a triangle that's been extended back. This is a triangular prism. And finally, we have the cylinder. Now, the prisms are kind of all related with the same formula, but the others have their own unique formula to find the volume or the amount of space inside of the figure. There's length, which is one-dimensional, area, which is two-dimensional. Think of like the area of a chalkboard, and then volume is three-dimensional space. Okay, so this shape here, it is a pyramid because it meets at a point at top, and the base is a triangle. So this is a triangular pyramid. And let's define what a vertex is, an edge, and a face. So a vertex is a point on that the solid makes. So in this picture, there's 1, 2, 3, and 4. And an example is like 0.0. An edge is just a side length of the figure. So we would have 1, 2, 3, 4, 5, 6. And an example would be like edge AB. Okay. And the faces are the flat two-dimensional, I want to call it a face, but it's like a entire side plane of the figures. It's a plane. So an example, well, let's see, we have this one here, this one here, we have the one in the back and the one on the bottom. So there's 4 faces, and a face is actually, it's a flat plane, but of course it's cropped, this one into a triangle. So triangle AOB is the face on the left there. All right. What about this one? Well, it is a triangle, right triangle looks like, that's been extruded or been pushed back here. And we're talking about the space in between those two triangles. And so that makes this a prism. Okay. And the edges, I've already outlined 6 of the edges. So there's 9 edges in total. There's those 2 triangular faces, and there's also this face, and the face on the bottom. So there's 5 faces, and the vertices, or the points on this solid, are these 6. Okay. A cross-section is exactly what this picture is saying. So if you take a plane, normally it's going to be a vertical plane or a horizontal plane, and you cut a solid, that intersection that it makes, that's called a cross-section. So this is the shape obtained by intersecting a plane, normally a horizontal or vertical, and a solid. And that picture shows exactly what that is. It's the red part of that picture is the cross section, which is a triangle in this case. So if I make a vertical cross section on this picture, that's like me taking a plane and cutting it like this. So what shape that makes is something like this. You can imagine cutting this like from the top down, like slicing, chopping it like you would chop like a vegetable in half. That's a rectangle. And if you cut it the other way, which I think is always a little bit easier to see, you're going to get, let's draw that in a different color. Now this is a prism. It's a hexagonal prism. So all the cross sections are going to be the same. And it's going to be this red part here. You can kind of see that if you were to cut it horizontally, that's what you would get. So it's a lot of visualizing in 3D here. Now this one's a little tough, but if you cut it vertically, just chopped it straight down, I think you would get this line here, and you'd get a line down there, and you would connect these. That would be the shape. If you cut it and then opened it up and looked at what the shape was, that's a trapezoid. And if you took this way, notice how the bottom and the top faces are circles, so you would expect this to be a circle too. Okay. And this is a really common question on the test is when you revolve a solid, so taking this triangle and spinning it around that line. So just imagine taking some points and spinning them. We're going to get a cone here. So if you spin a right triangle, you get a cone. And if you spin a rectangle, this is a square, but it's more like a rectangle. Okay. We're going to get a cylinder here. Okay. Guess those fives make it a square. Just now seeing that. Okay, so how do you find volume? Well, we'll start down here with the volume formulas. So the volume here is length times width times height, which is also capital B times H. And B is the area of the base. And I'll pass these out to you. You should get this when we do the notes. This is the formula sheet that you get on the state test. It's probably going to be viewable like in the online module. But these are the 5 formulas here. And we have some area formulas here. But it's these 5 that are really going to help us out today. So I'm going to open these up right here. And we just did this one here. Okay. A pyramid, they're saying, is one-third capital B H, but the base here is length times width, because the area of a rectangle is just length times width. So you could also write this, if it is a box or a square pyramid down there, we could write it like that. Cylinders, it's the same thing as a prism, except the base is the area of a circle. So the volume formula is the base times the height. And the cone, I always remember, it's actually a third of a cylinder with the same dimensions. So we got all those, and we'll talk about the sphere a little later. So Here we have a prism, because we have the two triangles are consistent on the top and the bottom. So the volume is base times height, and the base is this, or also you could use that. But the area of a triangle is 1/2 base times height, little base, which I could even just, to avoid using the same variable, I can just put in the 3 and the 4, times h, which is 6. This is the height of the prism. So this is going to be 6 times 6, which is 36. And we put our units there as centimeters cubed. Okay. Here is a cylinder, which we can look over here. We're going to use this formula there. So the radius is 3, and the height is 5. So we're going to get 9 times 5, which is 45 pi centimeters cubed. It's common to leave pi in your answer. However, if you want to use 3.14 and multiply, you can do that too. Now, this is how they extend a little bit. So they're going to give you a scenario where something's being cut out of the solid, or you're subtracting something. And you need to find the volume of the remaining solid. So we have a cube or a rectangular prism that has squares on it. And in general, let's go ahead and write down the formula with some pictures first. So it's going to be the volume of that cube minus the volume of that cylinder. And for any sort of box, three-dimensional box, the formula is just base times height. And we know that for the cylinder, it's this formula. Okay? So the base of a cube it's really just going to be 6 times 6, and the height is also 6. So that's special about a cube. You can just multiply all the lengths together, and they're all the same. And then the radius here, we have to be careful, is actually going to be half of the 5. And the height, h, is the height of that cylinder, which is also 6. Okay? So I got, when I did this, see if you can get the same thing. You got to double check me here. When I squared that number and then multiplied it times 6, that's what I got. And then the answer, which you probably want to put in a decimal, because one of the parts has pi, one of them doesn't, which I got 98.2 inches cubed from that. Okay? You got the formulas here. Let's just do a couple more. I know it's probably a little longer than I intended, but that's all right. So this is a cone. This is a cone that's been skewed a little bit, but the formula is still the same. A third of a cylinder. So R is not 30. It's this length, which is 15. And what do you think the height is of the cone? It's the height. The height's from the base all the way to the top point. Okay, which is 25. Okay, and this is going to end up being 1/3 times 15 squared times 25 times pi. And all that stuff multiplied together is going to be about, or I can give you the exact answer, which is this. And as a decimal, approximately that many cubic feet. So cubic feet, remember, that's a space. 1 cubic foot is a foot by foot by foot. It's like a little box. So there's 5,800 of those little boxes. So this is a very, very large cone. Not the kind of cone you get at the ice cream shop. Okay, and then this one is our pyramid formula. And the base on our pyramid is a square. So capital B is just going to be 8 times 8. And the height is a little bit tricky though. This is called the slant height. The real height, just like for the cone, is from the base to the top point. So we actually have a little bit of work to do. But I can complete this right triangle here, where this is actually going to be 4. And we can do a little bit of Pythagorean theorem here. So 4 squared plus h squared equals 9 squared. So 1681 h squared. So we get 65. So h is the square root of 65, which is around 8. Okay, so the square root of 65, and if you multiply all those numbers together, you're going to get around 172 cubic inches. Okay, so remember the height is from the base to the tallest point. Okay. And our last formula is the sphere. So the sphere is only dependent on one thing, its volume. It just depends on what the radius is. So the formula is actually pretty easy to use because the only thing you need to plug in for is the radius. So we can do this one quickly. The radius here is half of 15. So the volume is 4/3 pi and then 7.5 cubed. Okay, so the volume is going to be, I'd like to see you work that out and see if you can get this as your answer. Alrighty, thanks for sticking towards the end. It'll be worth it. It's just important that we know how to use these formulas. Probably the most important thing to read this sheet is knowing what capital B is, and that's just the area of the base. Capital B is two things multiplied together. Generally, it's a box, square, or rectangle. All right,